everyone. So we're looking at chapter 2 for this lecture. We're going to look a little bit at some of the common research strategies. We'll take a second to look at some imperfect methods like intuition, common sense, and pseudoscience, and then shift to embracing more of a scientific, critical thinking attitude. We'll look at some of the ways we can actually conduct research, and then some of the ethical concerns and guidelines that can come with doing different types of research studies. So the first thing to look at here is that most of us, when we're trying to answer questions in our lives, don't necessarily use the scientific method, which we'll talk about in a moment. A lot of us rely on things like intuition and common sense, believing that those things are enough to kind of answer the questions that we have in front of us. And they can help us quite a bit, but they're definitely not free of error. Intuition we can define as like a gut feeling about something, and common sense tends to be what most people would agree on. And these things can take us a long way. I'm sure you've met somebody and your gut or your intuition has told you like, we're going to be really good friends, or there's no way we're ever going to get along, right? And oftentimes your gut can be very correct when it comes to some of your kind of personal queries that you might have. But these things are definitely not free of error. For example, I have on here, maybe when you are interviewing someone for a job, you might rely too much on gut feelings and maybe not enough on the information and research and maybe their background check and all of that kind of information. So it's important to recognize intuition and common sense, but not to rely on them 100%. There's a great example of this in football, and I love football, so of course I have to bring it up here. The Monday morning quarterback, that idea that everything seems clear, like in hindsight, right? Intuition and common sense are very commonly used in hindsight. In fact, that's one of the very big limitations to using those two things, is that people tend to have this like, I knew it all along phenomenon. Well, why did you go for it on 4th and 2? Well, because I knew we could convert, right? Versus if you went for it and didn't make it, right? Oh, I knew it was a mistake. You know, we tend to have what's called the hindsight bias, thinking that we knew all along what was going to happen. We also tend to be very vulnerable to overconfidence, that we think we know more than we actually know. What's true and accurate for us isn't always true and accurate for other people. And so we tend to overestimate what we know, especially when we're drawing on our own personal experiences. Now, intuition and common sense are very much in the realm of something that we can call pseudoscience. Anything that has pseudo in front of it means it's not quite whatever comes next. So pseudoscience means not quite science. It's a body of knowledge, methodology, belief, or practice that is claimed to be scientific or made to appear scientific, but does not adhere to the scientific method, lacks supporting evidence or plausibility, or otherwise lacks a scientific status. Now, there are an incredible number of things that fall into the realm of pseudoscience. It tends to be known as fringe science or pop science, and it's very interesting and popular stuff, but it's stuff that sometimes on the surface appears scientific, but when you dig a little bit deeper, lacks any kind of scientific evidence or plausibility or scientific status. So things like aliens, right? Do aliens exist or not? Ghosts, ESP. I almost said ESPN, but I stopped myself. ESP, extrasensory perception, people claiming to be able to tell the future or read minds. All sorts of these very interesting things fall into this realm, and it can be a little bit dangerous when people believe it to be true, believe it to be scientific, when it's really more in this realm of like intuitive common sense and lacking that scientific status. So just something to be aware of. Pseudoscience is a very popular fringe pop culture science kind of a mentality, but it doesn't always adhere to the methods that we're going to talk about as we progress through the chapter. So in contrast to intuition and common sense, psychology is a science. Remember, back to the 1800s, psychology became a scientific study. Science comes from a Latin word meaning knowledge. It's a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Now, if we were to look at some words that are synonymous with science, here's a whole list of them. These are all things that kind of define what is scientific. So science is observable. You can see it, you can measure it. It's objective, it's free of bias. Subjective means your own opinion, which would be intuition and common sense, versus objective is something that's more free of bias and kind of neutral. Empirical, meaning that it's dependent on evidence, right? That there is data that we produce from observation, and that evidence is going to guide us. Testable, we can generate a hypothesis and go out and test it. Falsifiable doesn't mean that something is false, but rather it means that we could show it to be false. So I could make an assertion that all swans are white and then go out into the world and try and falsify that. If I could find a swan that isn't white, I would very easily falsify that statement. Science is also replicable, right? People can repeat it and do it over and over again to make sure that they're getting similar results. It's systematic, it's organized and formalized, and it's peer reviewed. Other experts in the field are looking at the information and seeing if it holds up. So all of these words go with science, right? And to build on that just a little bit more, a scientific attitude, when you embrace that over more intuitive, common sense kind of mentalities, you are curious, skeptical, and have humility, right? You want to know more. You're curious. You go and you want to find out more information, but you're skeptical of it. You ask questions like, where did this come from? Does this person have the expertise to back up what they're saying? And then you have humility. You're willing to admit when you're wrong and start over. And I don't know about you, but I love my phone for this, right? My phone is like my source of scientific inquiry all the time. At least once a day, somebody says something and I'm curious. I go right on my phone, I open up like the internet and I type in and search for something to find an answer. So I'm curious, I want to know more, but I'm skeptical. Who wrote it, right? I was just the other day trying to look up, is a hotel or an Airbnb safer in terms of like COVID and, cleanliness. And when I was looking that up, who wrote this article? Was it the CDC or was it some random traveler, right? I'm skeptical. Is there an agenda? Is the person who wrote it, an affiliate of Airbnb? And so they have something to gain from the fact that they're saying Airbnbs are safer, right? So you have that skepticism as part of your inquiry. And then humility. If I don't get the answer, I'm going to go back and search again or look for other ways to find out that information. So when you're thinking scientifically, you don't accept arguments and conclusions blindly. You question the questions and you question the answers and you want to know more and you have that skeptical scientific attitude. And I hope that you watch the video that I have linked in the lecture on Canvas with the aliens. There's a really wonderful little documentary on aliens and other explanations for them. And it gives you some great opportunities to think critically about why aliens might or might not exist. So just to build on critical thinking just a little more, to elaborate, I love this, right? Just go to criticalthinking.com and click on answers, right? The absolute opposite of critical thinking. But again, when you're thinking critically, there are 7 principles that we tend to follow. You're skeptical, as I just mentioned, right? You wonder if there's an agenda, right? What does somebody have to gain or lose from the assertions that they're making? You examine definitions of terms, running with that idea of aliens. How are we defining alien, right? Are we defining alien as a little gray, green, like man, like in Signs or in so many of the movies that we see about aliens? Or are we defining it as a bacteria, right? How you define something can very much shape the way that you're going to view it and interpret it. You want to be cautious in drawing conclusions from evidence. You want to look more than just at the surface. For example, if you have a friend who, let's say they were sick and they took echinacea and they feel better within a few days, is there something else that might explain that? And that kind of piggybacks on number 4, consider alternative interpretations of findings. What else could explain why your friend might have gotten better? Was it the echinacea? Was it time? Was it the expectancy that it would work? What are some other reasons or interpretations of the findings that you're having? The next 2, don't oversimplify and don't overgeneralize. You have to walk the fine line in between. You don't want to make things so simple that it just doesn't seem plausible, but you don't want to overgeneralize to everyone either. Right? After the Columbine shootings years ago, or after many of the school shootings, You often hear school psychologists talking about, well, the students, they were listening to Marilyn Manson and, this was back years ago. They were listening to, dark music and wearing trench coats, and that's why they committed those shootings. Right. Well, it's probably way more complicated than that. That's a huge oversimplification and overgeneralizing to lots of people who probably perform those similar behaviors, but would never do a school shooting. So you have to be very careful when you're drawing conclusions from evidence, and you never want to make belief changes based on just one study. You can almost always find an article that will completely contradict what the other article said. And I had a great example of this in college. I had a professor. I took a nutrition class. I'm not sure why. It sounded interesting at the time, but I'm not the healthiest, most nutritious person, right? But I took this class, and the teacher gave us an article telling us why butter was the best thing in the world, right? Don't eat margarine. Margarine is the devil. Only eat butter. It's good for you, right? And so I went home, threw away the margarine. I was on my path to healthiness, right? And then we came to class the next day, and she asked us, how many of you threw away the margarine and went and bought butter? And a lot of us raised our hand, right? We were on the path to being nutritious. And then she gave us an article that said the complete opposite, right? That margarine is the best thing you can eat and that butter is the worst thing you can have, right? So there's always something to contradict. You want to read more than one article and make sure you're not changing your beliefs solely based on one study. Now, you'll see a lot of headlines. The point of this idea of thinking critically is you want to be what's called a critical consumer of information. You don't want to just accept things blindly, because when you do, you can be very easily manipulated and misled. So you always want to have that critical eye when you're looking at headlines. And these are very popular in our culture, kind of little catchy clickbait headlines. So for example, beer tax hikes drive down gonorrhea rate. Right. So the simple explanation for this is that by taxing beer more, we're driving down rates of gonorrhea. Right. There's probably other explanations in place. Right. How are we defining these things? What are the other things going on here? What else could account for the change? Other ones, sugar rush to prison. Study says lots of candy could lead to violence. Maybe. I eat lots of candy and I'm not a violent person. Right. How are we defining lots of candy? My definition of lots might be very different than yours, right? But looking at definitions of terms, what is violent behavior, and so on. Eating pizza cuts cancer risk. I eat lots of pizza, so I should be safe forever, right? But when you read the article further, it's one specific type of pizza, right? And what is it about the pizza, right? Not every pizza is the same, right? So are we talking about the sauce, or is it the cheese or certain toppings, right? Again, trying to break these down and look beyond the surface. What Facebook users share, lower grades. How are we defining using Facebook? How are we defining lower grade? What other variables might explain why people are having lower grades? So again, digging deeper. And finally, right here, we can't see it below this, right? Have more sex, make more money, right? So what is it that is explaining this? Does it go the other way? Maybe if you make more money, you have more sex, right? It's one way or the other. There might be other explanations for these behaviors. And so it's really important to be that critical consumer of information and always dig a little bit deeper. Read the definitions of terms, think critically, and don't just accept things blindly. Be that critical consumer of information. So when psychologists are thinking about the world, we use science, right? We use these scientific principles we've been talking about, the scientific method to answer our questions that we want to know more about. And the scientific method, something I'm sure you all have learned about many times throughout your education. It's an approach to knowledge that relies on collecting data, generating theories, producing testable hypotheses, and then going out and testing them empirically. It's a very circular process of gathering information, right? And it goes round and round and round so you answer the question at hand. And a couple of terms in here, a fact is an objective and verifiable observation, right? I could, for example, right, I'll just see what's next to me here. My daughter's Lunchable, right? I'll try not to break her crackers, right? I could take her Lunchable, and she's watching me very closely. I could take her Lunchable, and if I let it go, it falls, right? Like it drops to the table. She's growling at me. I won't break it. It drops to the table. That is an objective, verifiable observation that you all can witness. Now, if I let go of it and it didn't fall, you would remember this day forever as the day that I levitated a pepperoni pizza Lunchable, but it fell. It's an objective, verifiable observation. You could then make a theory to systematically explain why that happens, right? The theory of gravity and relativity. Thankfully, I don't have to come up with that. And from that theory, you can make a hypothesis, a specific testable prediction that if I were to grab a piece of paper and let it go, it would fall, right? And so facts lead to theories, which lead to hypotheses, and then we can go out and test them through a variety of methods to examine those claims and see how true or untrue they might be. Lots of different ways that we can actually conduct research. We'll talk about a couple of the big ones. These two are a little bit smaller, but they're very commonly used. We can use something called naturalistic observation to conduct research, where we watch people in their natural settings. The title of this is very informative. We observe people in a natural environment rather than in a laboratory. This is kind of like people watching with a purpose, right? Maybe you're seeing how many times kids are fighting on the playground or playing with a certain toy. You're observing and recording information. And the downside is you might not know why people did what they did, but you do get a very unbiased kind of natural behavior that you can keep track of and chart. Case studies look at an individual or maybe a handful of individuals in great detail. So maybe you're studying a group of people with a certain disorder or disease to understand that better. You're examining a small group or just an individual with like a magnifying glass, right, under a very high-powered lens. And the downside is you might not be able to generalize to everyone, but on the upside, you might be able to understand that phenomenon in pretty good detail. Much more common than both of those, survey research. I guarantee almost all of you, if not every single one of you, has participated in a survey. It's just a very easy research technique in which we give you a questionnaire or an interview to gather some information, right? And when we do this, it could be as simple as how many of you have taken a class at Moorpark, and you would raise your hand, right? Or how many of you are taking more than 3 classes, and you could raise your hand to indicate that. So it can be written, it can be verbal. This can be something that can be mailed to you or asked over the phone, but we're gathering a lot of information very quickly. Surveys are used all the time whenever we're trying to figure out and kind of gather some data to get some statistics and make some claims. Now, when we're doing a survey, we're interested in a certain population. Everybody that we are interested in would be the population. We don't have to ask everyone in a population, and sometimes it's actually not even possible. What we can do is just get a little sample, a small part of that population that we're interested in. So let's say I want to know how many units the average Moorpark College student takes. Instead of asking every single Moorpark College student, I can just ask, maybe 1,000 students or 500 students, whatever small group that I choose, as long as I make that sample random. What that means is that every person has an equal chance of being included. So maybe I get all of the student ID numbers and I ask every 10th number, or I pick out of a hat from all of those numbers, and everyone has a randomly equal chance of being included. If I only ask, for example, my psychology students, right, I'm taking a sample of convenience, and that might not be accurate. Really easy way to see how this might not be accurate. I teach human sexuality, so I'm going to pull you an example from there. Let's say that I wanted to know about the average sexual behaviors of women, right? If I wanted to do that, I don't have to ask all women. All women would be the population. Instead, I can just get a sample, but that sample has to be random. If I went out and I only asked prostitutes about their sexuality, I'm not going to get an accurate idea of what the average woman's sexuality would look like, right? As part of my random sample, I might want to ask a couple of people who are prostitutes and people who are celibate, people who are in a relationship, and people who are single, right? I'm going to want to ask a wide variety of people to make sure that I get a good sample so I can draw conclusions to my population. Another thing that we do a lot of in psychology is look at correlational research. the naturally occurring relationships between two or more variables. Now, a variable is just anything that can vary, anything that can have different values or change over time, an element, feature, or factor that is liable to change. And when we're looking at variables, what we do is we pick any two variables and we can talk about how strong or weakly related to each other they are. Strong or weakly correlated to each other would be another word. So I can take any two things, like I can take how much time you spend studying and your GPA and say they are very strongly correlated or related to each other. And when we talk about the strength of a relationship, we use a numerical indicator called Pearson's R, the Pearson product moment correlation coefficient, or Pearson's R for short, which is a number that ranges from -1 to +1. And the closer it is to -1 or +1, the stronger that relationship is going to be. If it's right around 0, then we say that there's almost no correlation between two items. So you can literally take any variables. I just have a random list here, and you can talk about how strong or weak you think the correlation might be. So for example, I could say that the amount of money you earn per year might be very strongly correlated to the number of appliances you own. Or hopefully the number of hours you spend studying is strongly correlated to GPA. Or your intelligence might be strongly correlated to, I don't know, let's see, the number of times you've been arrested, right? Or the number of years smoking a pack or more cigarettes a day would be strongly correlated with lung problems. So you can talk about any two variables and their connection or correlation to each other. And you can plot this on a graph, which I talked about in the textbook, or you can also plot this and define this by a numerical indicator called Pearson's R. Now, the tricky thing with correlation is there's a little phrase that you'll learn if you go on in psychology, that correlation does not mean causation. Just because two things are related to each other doesn't mean that they cause each other. There might be other things going on. And this is a really important principle of correlational research and statistics and research methods in general. So for example, if we look at this chart, right? If you look at this, on this side, we have drowning deaths. And on this side, we have ice cream consumption. And so you can see here that as ice cream consumption goes up or becomes more frequent, so do the number of drowning deaths. So the easy headline here is that eating ice cream leads to drowning. We can conclude very clearly, right, from this graph that the more ice cream you eat, the more likely you are to drown, right? This would be me, right? If I'm going down, I'm going to hold up my ice cream. I'm going to make it through this, and then I'm going to eat that ice cream cone. But the key here is that you have to look at, are there other things that could explain both of them? In the summertime, when it's hot, people are more likely to go swimming, so the number of drowning incidents goes up, and people are more likely to eat ice cream, so ice cream consumption also rises. So it's totally possible that eating ice cream and drowning have no relationship to each other, that they're both explained by a third variable, right? So you have to look at, are there other things that can explain what's going on, what we're seeing? Similar example in The Simpsons years ago, right? That as ice cream sales go up, so do murder rates, right? So ice cream sales are increasing murder, right? Again, in the summertime, people tend to be hotter and they're more agitated. When people are hot, they tend to be more angry, so violent crimes tend to rise. What are the other factors that might be explaining what we're seeing? Another example, I love this one, right? The number of people who drowned by falling into a pool and films that Nicolas Cage appeared in, right? Clearly, Nicolas Cage is killing people. He's drowning people, right, by appearing in movies, right? Again, you can take any two things and talk about how related or unrelated they are to each other. There's almost always something else going on. So you always want to make sure you're considering, what are the third variables that might be present? What are the other explanations? What is the directionality effect? It might be going one way or the other. One last example, as our global temperatures go up, right, we could see here that the lack of pirates is causing global warming. As our temperatures go up, we have less and less pirates. So clearly the pirates are causing global warming, or global warming is reducing our pirates, right? Again, piracy has fallen off over time, right? And our temperatures have increased over time. probably not related to each other in any way, shape, or form. So just something to remember, correlation does not mean causation. Just because two things are connected to each other does not mean that they cause each other. So just something to keep in mind when you're doing correlational research. One last type of research to mention here, the experiment. Experiments are another way that we can gather information. And the great thing about experiments is if you do them correctly, you can determine cause. You can say, I am fairly confident that X causes Y if you have set up your experiment properly. So you're deliberately manipulating selected events and then measuring the outcome of those manipulations. Now, whenever you do an experiment, you're going to have a bunch of different elements to it, but let's keep it really simple. For a typical, like, easy experiment, you're going to have an independent variable and a dependent variable, an experimental group, and a control group. The independent variable is always going to be the thing that you manipulate. What is the effect of X on subsequent behavior? It's the thing that you're going to change or manipulate and study. The dependent variable is going to be the thing that you measure. What is the effect of the independent variable on the dependent variable? And that's, I think, a great question to ask yourself, and then you can kind of figure out what those elements are. What is the effect of X on Y, or the independent variable on the dependent variable? The experimental group is going to be the group that gets the manipulation. They get the change. They get the thing that you're trying to figure out. And the control group serves as more of a baseline, right? So that group is going to allow you to make comparisons and see how they affected each other. So for example, if we want to know, does alcohol consumption have an effect on exam scores, right? What we could do is set up an experiment where we had participants drink alcohol, take exams, and then we can measure and compare the groups that are involved. The independent variable in this case would be alcohol consumption. What is the effect of alcohol on exam scores, which would be the dependent variable? The experimental group would be the group that gets alcohol. And then we might have a control or baseline group that doesn't get any alcohol, and they would be the one that we can make comparisons with. Now, there are some ethical guidelines in place to protect participants. These have not always been present. And when we get to some of the social psychology experiments later on, and also in the learning unit, we'll talk about some unethical experiments. But the APA, the American Psychological Association, has made guidelines to ensure that people are treated with dignity and that their rights are protected when they participate in research. Your participation should be voluntary, right? You choose whether or not you want to participate. I can't force you to participate. And it's based on informed consent. We want to make sure that you know what you're getting yourself into. Now, I can deceive you just a little bit, but I have to do something called debriefing afterward. If I deceive my participants, I just have to make sure that I correct and explain that after. I can't expose you to anything harmful or dangerous. I have to make sure that I don't hurt or harm you in any way, right? We have to respect your right to privacy. Any kind of harmful or painful procedures on animals must also be thoroughly justified. And you have to gain approval from a host institution and a review board before you can actually go out and conduct your research. So there's all sorts of these ethical guidelines in place to make sure that participants aren't harmed or coerced whenever they're participating in research. Now, just to wrap up, I have some kind of fun suggestions for further learning. If you want to know more about pseudoscience or any of these topics in here, there was a couple of great shows that were on TV, and they're over now, but you can easily find them online. Mythbusters was all about debunking, scientific or pseudoscientific myths. Curiosity, the same way, investigating common questions and trying to find out the answer. I thought there was a really fun show called Lost Tapes. It's a little cheesy, but I think it's interesting. They take things like Bigfoot, Chupacabra, Mothman, kind of common myths, and try and debunk them through more scientific methods. And then a wonderful book called The Demon Haunted World, Science as a Candle in the Dark. This book by Carl Sagan is all about science versus pseudoscience. And it goes over things like aliens and ghosts and religion and all these very interesting pseudoscientific topics in an effort to explain the differences between science and pseudoscience. So that concludes the lecture for chapter 2. I hope you check some of these out if you're interested, but I will see you all next time. Make sure you get going on all the other required weekly materials, and I will see you for chapter 3 next on neurons and the brain.